Okay, here are quiz 6 solutions for Math 112. You're given this triangle here and given some information. So B here is equal to 10, C is equal to 11, and the sine of A equals 3/5. So you might be used to seeing problems where angle A is given, but instead we're told the sine of angle A. But okay, determine the area of triangle ABC. A couple ways you can go about this. Probably the easiest way is if you happen to know this formula, that the area of a triangle equals 1/2 AB sine C, where A and B are any two sides with angle C in between them. So using the formula in this question, maybe I won't even leave this because I think it'll be confusing when people look at the solutions. It'll be 1/2 times the length of the two sides that the given angle is between. So 1/2 times 10 times 11 times the sine of that angle in between them, which is given to be 3/5. So the area is just this mess, whatever this equals. Let's see, 1/2 times 3/5 is 3/10, and 3/10 times 10 is just 3, and 3 times 11 is 33. So the area of this triangle is just 33. But it gets a little bit more complicated when you're asked to determine length A, so determine this length out here. And the easiest way to do that is to create some right triangles. And so the reason I ask these questions well, I'll just go about and solve it. Creating some right triangles here, you know that the sine of A equals 3/5. And the sine of A, I give this a name, maybe I'll call this D. Using SOHCAHTOA, the sine of A is equal to the length of the side opposite A, so D, divided by the hypotenuse, which is 10. And so since I know that the sine of A is 3/5, I got that 3/5 is equal to D over 10. And if you solve this equation, you'll see that D is equal to 6. Either because 3/5 is the same as 6/10, or multiply both sides by 10, and you get 30/5, which just simplifies to 6. But that's not the answer to the question. That just tells you this height right here. Note that at this point, you could use maybe a more familiar 1/2 the base times the height formula. 1/2 the base, which is 11, times the height, which is 6, would be 1/2 times 11 times 6, which give you 33 for this area up here, had you not already figured it out. But anyways, back down here to part B, we're trying to figure out what A is here. To figure out A, one way I could do it is if I knew angle B. Unfortunately, I don't. Another way I could do it is if I knew this length right here, which I also don't know, but I have a means of finding. And the reason I want to find this length is then I have a right triangle here, and I know two sides of a right triangle, so I can figure out the third. So to figure out this length in red here, I'm going to first figure out this length from here all the way to there. And the way I'll do that, well, you have a couple of options, but I think the easiest way to do it is note that you have a right triangle on this side. And one length, I don't know, we'll call this maybe E. I got that E squared, doesn't look like it's squared, plus D squared, which is 6 squared, is equal to the hypotenuse, 10 squared. So if you solve this, you see that E squared is equal to 64, and therefore E is equal to plus or minus the square root of 64, which is 8. And since we're talking about lengths, we know that it's exactly 8. So I got that E equals 8, so therefore F over here must be equal to 3. Where'd I get that from? Well, if this whole thing is 11 and this much of it is 8, I have 3 left over. Okay, so now I have this triangle here, and I know that one side length is 3 and one side length is 6, and the other one is A, which is what I'm trying to solve for. And again, using Pythagorean's theorem, I got that 3 squared plus 6 squared must be equal to A squared. So 9 plus 36, which is 45, is equal to A squared. And so A is equal to the square root of 45, which it turns out is equal to 3 root 5. I don't really care which of those you give me. Either one will serve as the answer. Had you still not been able to find out the area here, but you happen to know Heron's formula, you now have all three sides of a triangle, so you could figure it out that way. I think it's a lot easier to find it using one of these ways, though. Okay, number two, rewrite this expression so that it does not involve trig functions. In other words, simplify this mess. The trick that we saw in class to do these is to change the problem. instead of making it the tangent of all this mess, arc sine of x divided by y, just make it the tangent of t. In other words, let the stuff on the inside be equal to t. So let arc sine of x over y just be equal to t. And then what I'm going to do is I'm going to use this information over here to draw a triangle, because once I have a triangle, I can use that triangle to answer this question, which will be my answer. So if t equals the arc sine of x over y, then the sine of t is equal to x over y. And so you draw your triangle. Make sure it's a right triangle so that you can use your trig identities. Arbitrarily throw t down here in this corner. The sine of this angle t is the ratio of the length opposite over the hypotenuse. So I can call this x and this y. And then staring at this picture, I can figure out the tangent of t. To figure out the tangent of t, I'll need to say it's the opposite length over the adjacent length. So I'll have to figure out this length right here. But I can figure out that length. Maybe I'll call it a, because a squared plus x squared equals y squared, the old familiar Pythagorean theorem. So a squared is equal to y squared minus x squared. So a is equal to the square root of y squared minus x squared. And finally, I can figure out tangent of t. Tangent is just opposite, which is x in my picture, divided by adjacent, which is the square root of y squared minus x squared. Works kind of all over the place, so I'll put a box around this so you can tell where my final answer is. And then I will call that good.